So looking at this here, what we're doing today is we're starting chapter 3. Chapter 3 is going to be solving quadratics. And the first thing we're going to do in solving quadratics is factoring. But we're going to do distributive property first. It's going to help us kind of see what factoring is. And then the rest of this, we're going to do one example of this, and the rest of it's actually going to be factoring. Now, distributive property, you've gone over this before, we went over in Algebra 1, is we multiply through. So when I distribute, we would do 4x times x, which would give us 4x squared. Then we do 4 times negative 3. Well, 4 times negative 3 is negative 12. And we have the x. And after we finish with 4x, now we do negative 5 times x. And negative 5 times x is negative 5x. And negative 5 times negative 3, well, a negative and a negative make a positive, and 5 times 3 gives us 15. So we're distributing, we're multiplying through. Any questions on this here so far? Now, the next thing we would need to do is we need to combine like terms, and we have 2 like terms here. It'll be these two here. Because 4x squared, there's no other terms with x squared, but negative 12x minus 5x is going to be negative 17x, and then we have plus 15. And that's it. So when we distribute, we multiply through. Now, what we're going to be doing today is factoring. So we're going to be going backwards. So when we factor, we're going to start out with this quadratic and take it back into this form. We're going to split it back apart. Factoring is almost our distributive property, undoing the distributive property. And one thing I want to kind of draw attention to is the fact that our middle term, this here, this middle term, it really comes from the first term, 4x, the highlighter, 4x times negative 3 and negative 5 times x, because negative 5 times x didn't give us that. There we go. Because what negative 5 times x gave us the negative 5x. Highlighter. And the negative 4x times 3 gave us the negative 12x, and those combined to give us the middle term. That's going to be helpful later on. And that gives us our middle term. And we'll come back to that here in a little bit. But what we're going to be looking at is factoring. That's what we're going to be doing today, tomorrow, and then we'll use it to solve on Friday. Or not Friday, Wednesday. We'll use it to solve on Wednesday. Now, there are a few main steps that we're going to use for this here. I already have them written out. So if you want to, on the previous where it says factoring A, we'll write the steps out here. So under here, our main steps, so we got 5 of them. First is to find a greatest common factor. The first main step, and I'd write these steps down, is to find the greatest common factor. We want to see, is there a number divisible in all terms? Our second step is going to do 2 sets of parentheses. Our step number 3 is to find the signs. Steps are there. Find the signs. If the constant term is positive, the signs are the same and they match the sign of the middle term. If the constant term is negative, the signs are opposite. And all of these steps are going to make more sense when we get into it and actually start using it. But these here are the kind of the main steps and guides to how we do this here. Step 4 is to find the factors of the first and third terms. And last but not least, the last step is plug and check. Plug and check. So when we're factoring these quadratics, this ax squared plus bx plus c, these are our 5 main steps. These will be the 5 main steps that we're going to be doing to solve these here. Let's write those steps down. You got them? So these here are going to be our 5 main steps that we're going to use to factor these here. So if you don't have them written down, I do have them up here on the board. And we're going to look at this first problem here. Now, greatest common factor. A greatest common factor is a number that is divisible by all 3 terms or divisible by everything, a part of it. So when we look at this here, 5x squared plus 15x plus 10. Is there a number that divides in all 3 terms? That has a common factor across all 3? 5, yes, 5 is a common factor for 5x squared, 15x, and 10, yes? So what we're going to do is we're going to factor it out. I'm going to divide it out of each term. Because 5x squared, if I divide 5 out of 5x squared, what am I left with? I'm just left with x squared, yes? 5 divided by 5 would be 1. Plus 15 divided by 5 would be 3x. And 10 divided by 5 is plus 2. Any questions on anything we've done so far? So all we've done so far is we factored out 5, yes? We divided each term by 5. The variable is not going to change because we're not factoring it out. I can write in here, almost what we did is we divided each term by 5. Because that's step number 1. We want to find the greatest common factor. We want to see, is there a number that will divide into all 3 terms? And it's 5. Okay, that's the first step. Now, what's the second step? We want to write 2 sets of parentheses with 3 spaces. Two sets of parentheses with 3 spaces. So if we look back at this first one here, how many terms were in the first set of parentheses? Well, we had 2, yes, 4x and 5, and a sign in the middle. So how many things do I have in that parenthesis? 3, yes? I have a number 4x minus 5. That's 3 things. The other one, x minus 3. I have 3 things, yes? So when we talk about the 3 spaces, we're going to have a term, a sign, and a term. A term, a sign, and a term. Number, variable, sign, and a number. So that's why we have the 3 spaces. Now, the first thing we're going to look at after doing that is to find the sign. We're going to find the sign. Now, both of those, when finding the sign, talks about the constant term. The constant term is the number without a variable, which in our case would be 2, because 2 does not have a variable. We have 3x and x squared. Those are both variables. Now, we're not worried about the 5, because at this point it's called a scalar. It's not a part of what we're factoring. We're wanting to factor the x squared plus 3x plus 2. Now, looking at this constant term, is the constant term positive or negative? It's positive, yes, we have plus 2. So if the constant term is positive, the signs are the same and they match the sign of the middle term. What's our middle term? It's positive 3, yes? So the signs for this here would both be what? Positive and positive. So b plus and plus. So I'm going to go back to this here. What was negative 5 times negative 3? A negative times a negative is a positive. What other two numbers are, so what would I need for also for, if they weren't both negative, what's another way I can multiply two numbers and it be positive? Is if they're both what? Positive. Because a positive times a positive is a positive. A negative times a negative is a positive number, yes?
Kalen DeFrancisco, please come to the office.
Because that's the only way it works. Because if one number is positive and the other is negative, we get a negative number, yes? The only way for two numbers to multiply together and be positive is if they're both positive or if they're both negative, yes? So here, they're both negative, yes? And we said the middle terms was negative 12 and negative 5x. So that gave me what? A negative, yes? So we look at this here. If it's positive, well, it had to be the same, and they are both negative, because we have this here, yes? So that's also true if it's positive and positive. Because if they're both positive, the signs are the same, and they have to both be positive. Do y'all see this here? Do y'all see how this works? So if this had been minus 3x, they would have both been negative. But since it's plus 3x, they're both positive. So it's just an easy way to see our signs, and we can check these off. Any questions on this so far? Okay. So that finishes step 3, and that brings us down to step 4. Find the factors of the first term and third term. Well, first term is x squared. Well, what are the factors of x squared? What multiplies together to give me x squared? X and x. There's only one thing that multiplies together to give me x squared. And if I just have one set of factors, I'm just going to write them down, because that's the only thing that works. It's x and x. And with all of these quadratics that we're going to do, we're always going to have whatever's squared. If it's x squared, we'll have x and x. If it's w squared, it'll be w and w, because that's the only thing that works. That's going to be there for all these quadratics. What are the factors of 2? 2 and 1. Are there any others? No, let's just put it in. 2, 1. Now, it seems like up to this point with how we put things in, the factors of the first and third term have been just throwing things down, yes? And that's fine. That's what we're going to do with most of these here, because our last step is plug and check, yes? Because with all of these here, the factors, the last thing we're going to do is we're going to check to make sure this is correct. Now, I know I keep jumping between these two, but I'm using this back as our example. 4x times x gave us 4x squared, yes? Negative 5 times negative 3 gave us positive 15, yes? Okay, so that's where we got the first, and because here if I do x times x, I'll give me back x squared, yes? Well, how did we get x and x? Those are the factors of the first term, yes? So in any of these factors, the first term and first should always give me back to this here. Why? Because it's the factors. Factors are the two numbers that multiply together to give me this, yes? Because x times x should always give me this. The first term times the first term should always give me the first term in this here. The last and last, 2 times 1, that's always going to be 2, isn't it? So if we look back here, 15, negative 5 times negative 3 will always give me the last term, yes? Well, yeah. Because if we're going backwards, these two multiplied together will always be that third term. The one that we're really focused on is the middle term. The middle term is going to be the one that's really going to change, because we have what? This and these here. Those are the ones we focus on when checking. Now, is it wrong to multiply all the way out? No. So I'll show you what I mean by checking here and all the way out. So when I check it, what I'm going to do is something particular. Is I'm going to do these and these. So I'm just going to do x times 1, the outer, and the middle 2. X times 1 is x, yes? 2 times x is plus 2x. What is x plus 2x? Is that the correct middle term? Yes. So this is factored. Now, I could have done the whole thing. X times x would give me x squared. X times 1 gives me x, 2 times x gives me 2x, and 2 times 1 gives me 2. But I don't do the x times x or the 1 times 2. It's x times x. We got those from the factors of x squared, yes? So since they're factors of x squared, it should give me the first term every single time. 1 and 2, since they're the factors of 2, the third term, we'll always get back to the third term. The middle term is the one that we need to watch out for. Any questions on this so far? Now, when we're checking it back, we're checking back to the one we're factoring. We're not looking back at 15. We're not looking back at the 15x. Because we factored out a greatest common factor. That greatest common factor, that factor of 5, changes what it's going to be. Any questions on any of this here so far? And if it feels like this is a lot of trial and error, possibly going to be a lot of trial and error, yes, it is. The more that you do these, the more of these that you do, the better you're going to understand them. Okay, these are a lot of guess and check, guess and check, guess and check. Plug stuff in, check, okay, it works, or no, it doesn't, we're going to fix it. So let's look at this one here. The first step is what? Greatest common factor. Is there a greatest common factor between these three numbers? 4. Because if you're not sure, because there at least is 2, because 4, 32, and 60 are all even, so it does go in at least 2. And you can check 4. We can plug in a calculator, 32 divided by 4. Okay, it came out evenly. 60 divided by 4. It came out evenly. So we can factor out 4. We'd write down 4. Well, 4x squared divided by 4 would just be x squared, because 4 divided by 4 is 1. Now, 32x divided by 4, well, we'll have x, and this would be 8. And 60 divided by 4 leaves 15. Is 15. Okay, we did that. What's our next step? 2 sets of parentheses with 3 spaces. Okay. Now we need to find the what? The signs. The constant term, is it positive or negative? Positive. So the signs are the same and they match the sign of the middle term. Positive. So these signs are both positive. Factors of x squared, well, that would be x and x. Yep. It doesn't matter, because if the constant term is negative, because again, our last step is check. So if it turned out we had the wrong sign, and we'll see that here eventually, either today or tomorrow, we can flip the signs and then check it. So that's why I put that last step check, is because we can throw this stuff down and then check it at the end. Because otherwise, it's going to take too much mental math trying to figure it out, which sign goes where. What am I looking at? Let's just check it. It's going to be easier to plug and check. And again, the more that we do, the more that y'all do, you will start picking up on the road signs for it as you do them, okay? So a lot of the stuff that I'm going to show you and teach you isn't textbook stuff. Like, this is what the textbook says. If you see this, this is what you do. A lot of it is, if you've seen them enough time, you start picking out what you're needing to do, okay? Factors of 15 are what? 1 times And so which one do you think we would use? 3 times 5. So I just pick one. Now we can check it. Because x times 5 is 5x. 3 times x is plus 3x, which is, that works, because that is what we wanted, yes? These are our factors. Now again with this here, the reason we don't check the first term, x times x, well that gives me x squared, yes? What's 3 times 5? 15. What were the other two numbers that could go instead of 3 and 5? Well, 1 and 15. And 1 times 15 is still going to be 15, yes? Are y'all starting to see how multiplying these two together and then these two together really isn't necessary in checking? Because those are always going to be the same when they multiply out. Because they should be 3 and 5, those spots should be the factors of 15. Where x isn't going to be the factors of the first. They're always going to give us the first and third term. Always give us the first and third. It's the middle one that can change, depending on how the numbers are set up. Questions on this here? Questions on any of this here? Okay. So a lot of this stuff here, so our steps are kind of tips and tricks. That's why I set these steps up, and hopefully these will help. Now looking at this here, first step, greatest common factor. Is there a greatest common factor? No. So we move on to step 2, which is 2 sets of parentheses with 3 spaces. I do the 3 spaces to kind of help you guys give yourself enough space inside there to write the terms, so that you have enough space to write the terms. Well, the 3 is positive, so the signs are the same and they match the sign of the middle term. So it's going to both be what? Positive. Because we have a positive and a positive, so they're both going to be positive. It won't always work out this way, that they're both positive. We could have both negative or one positive, one negative. But this rule does hold true every single time. All right, any questions on these first few steps? We good with these here? All right, what are the factors of 3? We're going to do 3 first. 3 and 1, yes? So, do we want to do 3 and 1 or 1 and 3? No. 3 and 1. Because again, I would plug them in one way. Just plug them in. Because again, in the end, we're going to check. Because if it doesn't work, our check doesn't work out, we'll change it. Now, the first term is 4x squared, yes? Well, 4 has some factors. Because we can have 1 and 4 or 2 and 2, yes? But it's 4x squared. Well, x squared is what? X and x. There's no way that changes, correct? I'll go and put x and x. Now the question is, do we want to use 1 and 4 or 2 and 2? Let's do 2 and 2. Now here, 2x times 2x is going to give me 4x squared, yes? Well, yeah, because those are the factors of 4x squared. It has to be. 3 and 1 have to get me back to 3. So the only ones we're really worried about are here and here. 2x times 1 is 2x. 3 times 2x is plus 6x. That gives me 8x, yes? Is that the middle term? No, it's supposed to be 13, so that doesn't work. So what I do before I kind of throw out 2 and 2 is I want to see if I can flip it. If I flip 2x and 2x, does that change anything? If I flip the 3 and 1, does that change anything? Well, no, it's the same thing. They just flipped, yes? Okay. Since here, because 2 and 2 doesn't change even if we flip anything and they're both positive. 2 and 2 doesn't work. So now we'll move on to 1 and 4, and I'll put 4 over here. So it didn't work, so I changed 2 and 2 to 1 and 4. Let's try again. X times 1 is X. 3 times 4 is 12. X plus 12x is 13x, and that's what we wanted, yes? And that's it. So a lot of the times on these here, it's just plugging those numbers in where you think they might work, check it. If it matches the middle term, you got it. If it doesn't, switch them up, switch them up. Most of the time, I will flip the x values to see if that helps, or we'll flip the numbers. It's just you pick one or the other and do it, and see if that works. And this here did, and that's our factors. Questions on this here? Any questions on any of this here so far? So let's look at this one here. 3x squared minus 7x plus 2. Is there a greatest common factor? Well, no. There's not one that factors into 3, negative 7, and 2. Since there's no greatest common factor, we move on to step 2. I think some of you already moved on to step 2. Step 3. Constant term. Is it positive or negative? It's positive, so the signs are the same and they match the sign of the middle term. So they'd both be negative. Since 2, our constant term is positive, the signs are the same, and they match the sign of the middle term, which is negative. Factors. Well, x squared will just give us x and x, yes? What are the factors of 3? 3 and 1. There's only 1, yes? 3 and 1. How about 2? 2 and 1. Do we want to do 2 and 1 or 1 and 2? Which one do we want to put here? 2 or 1? 2, 1. Because again, I would not get caught up on trying to see if you put it in the right spot first. Just throw them down. Because again, our last step is to check it. 3x times negative 1, negative 2 times x. Well, 3x times negative 1 is negative 3x. Negative 2 times x is negative 2x. That gives us negative 5x. Is that what we wanted? No. So what do we want to change? Do we want to change the 3x and x, or the 2 and 1? Doesn't matter which. We just need to change one of them. 2 and 1. Well, 3x times negative 2 would be negative 6x, yes? Negative 1 times x would be negative x, which gives us negative 7x. And that's it. That's what we wanted. Questions on this here? So we've gotten this here, seen the steps. And again, the more of these that you do, you'll be able to pick out where the factors go a little bit more easily. We're going to come back to this one here in a minute. I want to do this one first. I want to do this one first. So looking at this one here, is there a greatest common factor between 2, 5, and 7? No. So that means we do our 2 two sets of parentheses with three spaces. Two sets of parentheses with three spaces. So the constant term is -7. Since the constant term is negative, the signs are opposite. Doesn't matter which. I'm just plugging one, making one positive, one negative. We just have one of each. One's going to be positive, one's going to be negative. Now, if you wrote down negative and a positive, that's fine. That's fine. It'll just be a little bit different than what we're going to do here. But it's fine. We can do negative or positive. It doesn't matter the order, as long as we have one of each. Factors of 2x squared. Well, we have to have x and x. But the factors of 2 are just 2 and 1. We only have one set, correct? 2 and 1. What are the factors of 7? 1 and 7. So again, I'm just putting them down. I'm just putting them down on the paper because we only have one set, so we only have one choice. Well, because we could have done 7 and 1. We have another choice, but we only have one set of factors to choose from. So the last thing we need to do is check it. What is 2x times -7? That'd be negative 14x, yes? 1 times x is plus x, which gives us, is negative 13x what we wanted? Well, no, right? Let's switch 1 and 7. So 2x times -1 is negative 2x. 7 times x is plus 7x, which gives me positive 5x. Is that what we wanted? Yes, positive 5x? Almost. What's it up here? Negative. We're close, aren't we? The signs are wrong. They're the opposite, yes? Well, let's do that then. I'm going to flip the signs. Because if the middle term, when you check it, is the correct number, but is the wrong sign, is the correct number, but is the wrong sign, all you need to do is you need to flip the signs. So here, since we had 2x plus 7, we're going to make it minus. Since the other one was x minus 1, we made it x plus 1. So if you get the correct middle term, the number, but wrong sign, flip the signs, and it'll make it right. Because if we look back down here, well, it's going to be positive 2x now. And this here is now going to be minus 7. Well, 2 minus 7 is negative 5. It fixes it. So if you get the correct middle term but wrong sign, flip the signs. And that's it. Questions on this here? I want to look back at this one. So we might not get done before the bell completely, and I'll give you the answer as soon as the bell rings. But there's one thing I want to pay attention to. Is there a greatest common factor between 2, 7, and 6? Well, 2 and 6 there is, but not 7, correct? Okay. So we have our two sets of parentheses. Now, the constant term is positive, yes? So the signs are the same, and they match the sign of the middle term, which would be positive and positive, yes? So they're both positive. They're both positive. Now, factors of 2x squared. Well, we've seen this one already, yes? because the factors of the x squared are just going to be x and x. I'm going to do 2 and 1. Now 6 has some more factors to it, yes? Because 6 would be 1 times 6 and 2 times 3, correct? I'm going to do 1 and 6, just to plug them in and check. It's not going to work. I can tell you that right now. It doesn't work, because I did this first hour. But if we check it, 2x times 6 is 12x. 1 times x is plus x, which gives us 13x, yes? Now, we can flip the 1 and 6. Don't write this down, because we're not even going to check this. Looking at this first one, 2x plus 6. Is there a common factor between 2x and 6? Yes. Did we say that there was a common factor on the original one? No, because if I have it this way here, I could have factored the 2 out. If there's not a greatest common factor in the original quadratic, there's not going to be 1 in either set of parentheses. Because if there's a common factor between these two here, so 2x plus 6, there is, would mean there had to be 1 in the start. So if there's not 1 in the starting one, there can't be 1 in either set of parentheses. Does that make sense? So that means 6 and 1, I can't put the 6 with the 2x, because there'd be a common factor. And we know there's not 1 to start with. So that means I am done with 1 and 6, because there's no other way to put it, because we already checked the other way, yes? How about 2 and 3? So there might be 1 there. Am I restricted on how I set up 2 and 3? Can I put 2 with 2x? No, because they would have a common factor of 2. So what that means for me is I have to put 3 here, and I have to put 2 here. Now, again, that's one of the things I noticed as I was doing these, is if there wasn't a common factor to begin with, there can't be 1 here. Now this here is going to be the way it works, because there's no other way to set this up. And if we check it, 2x times 2 is 4x, plus 3x gives us 7x. And that's our answer there. Now, the other question you might have is what happens if they all fail? Is that a possibility? And yes. Because there are going to be ones that we cannot factor. There are going to be quadratics that we cannot factor. We have to solve it a different way. And we're going to cover at least 5 different ways to solve these. This here is leading up to the first one. So we're going over how to do this the first one. The last 2 ways we cover how to do these, it doesn't matter what they are or how they're set up. Well, a little bit how they're set up. But it doesn't matter what the numbers are. They will always work. There are 2 methods for solving these that will work every single time. Okay? And those will be the last 2 we cover.